Welcome back to Science and Amp Technology. Today we're delving into the fascinating history of computer hardware. Imagine a world where punch cards and vacuum tubes were the height of technological innovation. Picture the first personal computers, bulky and rudimentary by today's standards, but revolutionary in their time. Now consider the powerful machines we use today, capable of tasks that early computer pioneers could only dream of. It's been an incredible journey, and we're here to guide you through it. So, let's dive in and explore this incredible journey. Our story begins in the early 19th century when mechanical calculators and early computing devices laid the foundation for modern computers. The human mind craved efficiency and accuracy, and this desire led to the invention of machines such as Thomas de Colmar's arithmometer, considered the first successful commercial calculator, and George Boole's Boolean algebra that would later form the backbone of digital logic. But the real game changer was Charles Babbage's analytical engine. Babbage, an English mathematician, proposed this machine in the year 1837. Unlike its predecessors, the analytical engine wasn't just a calculator. It was designed to be programmable, making it the first steps towards automation. This machine, though never fully built during Babbage's lifetime, was to be powered by steam, reading instructions from punch cards, a method used much later in early digital computers. The analytical engine marked the inception of the concept of a universal computer, setting the stage for the computing revolution that was yet to come. Devices like Charles Babbage's analytical engine were the first steps towards automation. In the mid-20th century, electronic computers emerged, changing the game entirely. This was a time when innovation accelerated, and the world began to see the real potential of automated computing. The Electronic Numerical Integrator and Computer, or ENIAC, was a landmark in this revolution. Heralded as the world's first general-purpose electronic computer, ENIAC was a behemoth, filling an entire room and weighing nearly 30 tons. It marked the transition from mechanical to electronic computation, a monumental leap in technology. Hot on ENIAC's heels came the Universal Automatic Computer, or UNIVAC. UNIVAC was not just an improvement over ENIAC, it was the first computer made available commercially. It was a testament to how quickly this new technology was developing. Such was the impact of these machines that they laid the foundation for the digital age we live in today. We'll talk about the ENIAC and the UNIVAC, which were the pioneers of electronic computing. Fast forward to the 1970s and 1980s, where we witnessed the birth of personal computers. This was a time of rapid technological evolution, a time when the seeds of modern computing were sown. It was during this period that computer technology transitioned from being exclusive to research laboratories and business enterprises to becoming a household item. Enter Apple Inc., a company co-founded by Steve Jobs and Steve Wozniak. In 1976, they introduced the Apple I, a desktop machine that was a game changer. It was sleek, it was user-friendly, and most importantly, it was personal. Not far behind was IBM, a stalwart in the computing industry. In 1981, IBM launched its personal computer, known simply as the IBM PC. It was a powerhouse that solidified the role of personal computers in both the home and the office. Companies like Apple and IBM introduced iconic machines that brought computing into people's homes. The 1980s also marked the rise of microprocessors. This period was a watershed moment in the history of computing, where the power of a computer started to be condensed into a small, single chip. Intel, a company that would become synonymous with microprocessors, was at the forefront of this revolution. Their innovative designs, particularly the 8086 and 8088 microprocessors, were game changers. These chips were not just smaller, but they were more powerful and efficient. They enabled computers to perform more complex tasks faster and more reliably than ever before. More importantly, these microprocessors made personal computers affordable and accessible to the masses. Before this, computers were large, expensive machines that were out of reach for most people. But Intel's advancements in microprocessor technology changed all of that. This was a pivotal turning point in the democratization of computing, setting the stage for the explosion of personal computers in the following decades. Intel's 8086 and 8088 paved the way for the PCs we use today. The 1990s saw the advent of the Internet age, and computer hardware played a crucial role. This era marked a significant shift in how we perceive and interact with computers. It was no longer just about computational power or storage capacity. It was about connectivity. In the early days of the Internet age, dial-up modems were the primary means of connecting to the World Wide Web. These devices, noisy as they were, allowed computers to communicate over telephone lines, albeit at snail's pace. As the decade progressed, so did the hardware. Dial-up gave way to DSL and cable modems, increasing internet speeds by leaps and bounds. Computers were equipped with network interface cards, enabling them to connect to local area networks and later to the internet. This evolution of hardware didn't just connect computers, it connected people. It brought about a new era of communication and information exchange, shaping the world as we know it today. From dial-up modems to broadband, we'll discuss how hardware evolved to connect the world. Today, we're surrounded by powerful hardware. This statement rings true as we delve into the realm of modern computing power. Our current era is marked by the prevalence of multi-core processors, a leap from the single-core processors of yesteryears. These processors allow computers to perform multiple tasks simultaneously, boosting speed and efficiency. But the magic doesn't stop there. Welcome to the graphics processing units, more commonly known as GPUs. Initially designed to render high-quality gaming graphics, GPUs have now found their place in a wider range of applications. They've become integral to the world of artificial intelligence, powering machine learning algorithms and neural networks. What's more, the rise of solid-state drives, or SSDs, has revolutionized data storage and access speeds, making the spinning hard disk drives seem like a relic of the past. These advancements have not only transformed our day-to-day computing experiences, but also opened up new frontiers in gaming, virtual reality, and artificial intelligence. From multi-core processors to advanced GPUs, we'll explore the hardware that makes modern gaming and AI possible. What's next for computer hardware? Quantum computing and neuromorphic chips are on the horizon. These groundbreaking technologies could forever change our understanding and application of computing. Quantum computing, with its potential to solve complex problems in seconds, could propel us into a new era of discovery. Neuromorphic chips designed to mimic the human brain might redefine artificial intelligence. As we stand on the cusp of these technological advancements, the future of computer hardware seems to hold limitless possibilities. We'll discuss these cutting-edge technologies and their potential impact. That concludes our journey through the history of computer hardware. We've traveled from the birth of mechanical calculators to modern, powerful machines, witnessing the remarkable evolution. We've seen the rise of personal computers, the advent of the internet age, and the incredible power of today's hardware. The future promises even greater innovation with the advent of quantum computing and neuromorphic chips. If you enjoyed this video, don't forget to like, share, and subscribe for more exciting content on science and amp technology.